Hey everyone, welcome back. Today we're going to be taking a look at a C program because lately I've become interested in learning to program in C. And before you change the channel or turn to a different station, if you're at all interested or curious about C, but maybe you're a bit nervous about it, maybe a bit scared to take a look at it and you aren't familiar with it at all, today's going to be a very simple introduction and we're going to literally create our first program in the C programming language in about 5 minutes. So if I can do it, you can do it, and it's going to be very easy. So normally I give an introduction before my videos to do some explanations, but today we're just going to get right into it, except for one thing I'm going to explain is that there are several differences between C and other programming languages such as BASIC, but if you're familiar with BASIC, for example, there is one main difference I want to cover between C and BASIC, which is that C is a compiled language, whereas BASIC is an interpreted language. Now you may already know that computers only understand one language, or rather the microprocessor inside the computer only understands one language. It only understands pure machine code, which is essentially binary, zeros and ones, which is a digital representation of the electronic signals on the circuit board inside the computer. So since microprocessors only understand machine code, no matter what programming language we use, at some point that program needs to be converted into machine code. Well, with BASIC, that happens in real time, on the fly. As each line is getting executed, the BASIC interpreter converts that line of BASIC into machine code for the microprocessor to be able to understand and execute. Now with a program like C, or a programming language like C, that is what's called a compiled language. So instead of each programming line being converted into machine code in real time on the fly, one by one, as the lines are being executed, the entire program gets converted or compiled into machine code before the machine code program even starts executing. So that is one main difference that we need to understand before we create our C program, so that we'll understand what the compiling process is even doing. All right, so that's enough of an introduction. I will be doing some more explanation after we enter our program, but for now let's go ahead and get started, and I'll switch my screen over and we will enter our first C program. All right, here we are on our web browser, and for today's example, today's exercise, we don't even need to install any tools. All we're going to do is go to a simple online C compiler, which is why I did that brief explanation about how C is a compiled language. And so to find an online C compiler, I'm just going to search here for online C compiler, just like that. And you see the first one that comes up here is from a website called programiz.com. So I'm going to go ahead and click on that. And it brings you right here to this online C compiler, where we're going to be typing in our program here on the left side. And then when we run it, our output is going to show up here on the right side where it says output here. So now you can see that here's kind of a spoiler alert, that when you go to this website, it automatically fills in the source code or the program with this sample text here, which produces a hello world output example. And we're going to recreate this example ourselves. So if you want, you can just leave it in there and run it the way it is, but I'm going to start typing it from scratch. So I'm just going to erase this here. So here we are, we have a fresh slate for typing in our C program. And another reference I want to show you, which is something I'm going to be using later on in today's video, is a book that I found for explaining how to program in C. So obviously there are tons of resources for C programming, and there are lots of resources available that explain how to create your first Hello World program. But just to give you a preview as to what we're going to be looking at in a little bit, there is a book called The C Programming Language, and it's available as a free PDF download, or you can buy a physical copy if you want. But I'm just going to show you the PDF version here, and this is what the cover looks like. It's called The C Programming Language, actually ANSI C, because this book was revised. Up here it says second edition. The ANSI C Programming Language by Brian W. Kernighan and Dennis M. Ritchie. So the reason I'm looking at this book is because of the different resources that I've found. This one, in my opinion, has a very good, easy to understand explanation of the different parts of this introductory Hello World program. And if I scroll down here in this book a little bit, you can see it says right here, in C, the program to print Hello World is, and then it outlines it right here. So these are the different parts of the program. It says include stdio.h, then it has main, then a couple curly braces, and one printf instruction. So let's go ahead and type that into our online C compiler. And I'm just going to leave this first comment on the screen here that says online C compiler to run C program online. And this is how you make a comment. You just precede it with 2 forward slashes here. So this line will be ignored by the compiler. So the first line we want to include in our program, which is hashtag include. And then we have an open bracket like this, and then stdio.h. And we're going to explain these instructions in a moment when we go through the program, but this is including a header file that the program needs in order to operate. And then the next line we're going to type is main, and then empty brackets like this, so empty parentheses, just like that. And then I'm going to include an open curly brace, and it automatically puts in the closing curly brace for me like that when I press enter. And then I'm going to enter my single one line of code, which is print f, open bracket, hello world within double quotes. And then I'm going to put a backslash n. And then finally at the end of the line, I put a semicolon, just like that. And that is our completed program. So now if we go ahead and click run here, this online compiler will compile this program into machine code and execute it, and it should show us our output over here on the right. So let's go ahead and click run and see what happens. And there you go. Our output says hello world. So there we have written our first C program in just a couple minutes, and it's very simple. So now I'm going to go through and read the instructions or the explanation about this program that's shown in that book that I just showed you, because I think it describes it very well. And of course there are different parts to this program you can include, such as a return statement, and there's obviously a lot more to a C program than is what I'm showing here. But this is a very simple example that, as you can see, worked. And so let's go ahead now and read the explanation of these different parts of this introductory Hello World program. So I've just brought the book over here so we can read it together and see what this program is doing. And here it says, section 1.1, getting started. The only way to learn a new programming language is by writing programs in it. That makes sense? The first program to write is the same for all languages. Print the words hello world, which we've just done. This is the big hurdle to leap over it. You have to be able to create the program, text somewhere, compile it successfully, load it, run it, and find out where your output went. So using an online compiler such as this, it's very easy. It kind of bypasses all these steps that you would normally take in setting up an integrated development environment and putting all these development pieces together. You need to get an editor and a compiler and have it link your program together and produce this output, and then find where the output is. So using an online C compiler like this just kind of shortcuts that effort, so you don't need to go through all those steps. But normally, of course, if you're going to be doing C compiling and C programming on an ongoing basis with more elaborate programs, you would want to, of course, set up your own development environment. But this is the easiest way to get started, just by using a C online compiler like this. So let's go ahead and read the rest of the instructions how this program works. It says, with these mechanical details mastered, meaning once your development environment is set up and configured properly, everything else is comparatively easy. And this book explains how C is a relatively small programming language, and it's not that difficult to learn. Now, this book was written quite a while ago, and this is the second printing of it, but the C programming language, from what I understand, hasn't really changed all that much since it was created, and this book covers a lot of the information that is still relevant today. So it says here, in C, the program to print hello world is just what we typed in, include stdio.h, main, printf hello world. Just how to run this program depends on the system you are using. And it says, as a specific example on the Unix operating system, you must create the program in a file whose name ends in .c. So probably when you're typing in this program into a real editor in a development environment, you would save it with a .c extension. So you might save it as hello.c, for example, just as it says right here, such as hello.c. Then compile it with the command cchelloc. So on a Unix environment, you would use this cc command. Obviously, in our online editor, we're just clicking that run button, so it's a lot easier for us. And then it explains how that works in a Unix environment. So this obviously is what would happen if you're doing this manually and not using an online tool such as we just used. All right, so let's read about how this program actually works now. It says, now for some explanations about the program itself. A C program, whatever its size, consists of functions and variables. A function contains statements that specify the computing operations to be done, and variables store values used during the computation. So that makes sense. C functions are like the subroutines functions of Fortran or the procedures of functions of Pascal. I'm not interested in Fortran or Pascal, so we can just ignore that. Our example is a function called main. So right here, this main title is referring to a function, and we've titled it main. And it says, normally you are at liberty to give functions whatever names you like, but main is special. Your program begins executing at the beginning of main. This means that every program must have a main somewhere, and ours has a main. It only has a main. Main will usually call other functions to help perform its job, some that you wrote and others from libraries that are provided for you. The first line of the program, include stdio.h, tells the compiler to include information about the standard input-output library. So this stdio.h is the name of a library referred to as the standard input-output library. And it says here, this line appears at the beginning of many C source files. The standard library is described in Chapter 7, Appendix B. Okay. One method of communicating data between functions. So this stdio.h header file includes predefined functions that the computer can execute, such as this printf function here that we're using in our program. But let's go on and read here about how we can pass information into a function. It says, one method of communicating data between functions is for the calling function to provide a list of values called arguments to the function it calls. The parentheses after the function name surround the argument list. So that is shown right here. Our function name is called main, and there are some parentheses after it right here. In our case, the parentheses are empty, which means we're not passing information into this function. So you might have a function, for example, that calculates two numbers, and you might pass those numbers into the function so that it knows what values to use in its calculation. But in this case, our function called main is not being passed any values within these parentheses. They're just empty. But that's what it's describing here, that you can, if you want to, pass data into a function by specifying those argument names within these parentheses. But in this case, we're not specifying any arguments to pass information into this main function. All right, so let's see what it says here. It says, in this example, main is defined to be a function that expects no arguments, which is indicated by the empty list brackets here. Our empty list right here is just two brackets with nothing in the list. The statements of a function are enclosed in braces. The function main contains only one statement. So here is the statement right here. Printf hello world \n. So this is our statement that we're using inside this main function. And it says in our book here that the statements are enclosed in braces, and here are our braces right here. So before I go on, I just want to go back up to this little diagram or note here that explains the different parts of the program. And you can see here it says the include stdio.h. It says include information about the standard library. So that library contains functions such as printf, for example, and other functions that we can use in our program. And that's what this include line does. It just tells the compiler to include this library for us so that we can make use of the functions that are contained within it. And then this note here says define a function named main that receives no argument values. That's what this line here does, main with two brackets with nothing in between the brackets. It defines a function named main that receives no argument values because there are no arguments specified in between these parentheses. And then this left curly brace has a note here that says statements of main are enclosed in braces. And here our statement is enclosed with an open curly brace here and a closing curly brace right there. And then finally our statement here has a note that says main calls library function printf to print this sequence of characters. So this is a sequence of characters we want to print, hello world, and how it does that is it calls a library function called printf. So this printf word here, what it's doing is it's telling the compiler to call a library function which is within this header file called stdio.h. So this library here contains a function called printf, and when we use this word printf, it executes that function using the data that we're providing it here, which is hello world. And then finally it says here \n represents the new line character, and it will describe how that works as well. So you can see here it says hello comma world \n, but in our output it's not printing \n here, is it, right? So that \n is like a control character. It doesn't get printed, but what it does is perform a job of printing a new line, which means it will move the cursor down to the beginning of the line underneath where our output was displayed. So I just read that the main function expects no arguments because it is indicated by an empty list right here with these open and closed parentheses with nothing in between them. The statements of a function are enclosed in braces, which we just mentioned here. Our statement is printf. The function main contains only one statement, printf, hello world. A function is called by naming it, so we've named it by using that printf word, followed by a parenthesized list of arguments. So this calls the function printf with the argument hello world \n. So these parentheses here after this word printf, they work in the same way as this parentheses here after the function name main. So the main function can be passed parameters or values by indicating a list within these brackets or within these parentheses, just as the printf function can be passed parameters by indicating a list within its parentheses. And you can see here that the value that we're passing it is a string, hello, comma, world, \n. So we are passing a value into the printf function by putting that value within these parentheses. So we're calling a function called printf, and we're passing it a value, which in this case is a string that looks like hello, comma, world, \n. So it says here, it calls a function printf with the argument hello world \n. Printf is a library function that prints output. In this case, the string of characters between the quotes. A sequence of characters in double quotes like hello, comma, world \n is called a character string or string constant. So I'm sure you're probably familiar with string variables, but this is a string constant because it's not being stored in a variable, it's just a fixed string of characters. And it says, for the moment, our only use of character strings will be as arguments for printf and other functions. Okay. The sequence \n in the string is C notation for the new line character, which when printed advances the output to the left margin of the next line. If you leave out the \n, a worthwhile experiment, it says here, you will find that there is no line advance after the output is printed. You must use \n to include a new line character in the printf argument. If you try something like this, and you can see they've broken up this instruction to just kind of manually force this ending of the instruction to be on its own line, that doesn't work. You have to actually use the \n to tell the computer to move to the next line. You can't just break up your instruction like that manually onto a new line. So it says if you try something like that in the C compiler, it'll produce an error message. Printf never supplies a new line automatically, so several calls may be used to build up an output line in stages. Our first program could just as well have been written like this. So you can see we have our same include statement here, or directive, and then we have our main function. So here we have 3 printf statements, each of which is containing a different part of this phrase we want to have displayed on the screen. But since we don't include this \n in either one of these top 2 strings, then it will just print these words directly next to each other without going to a new line, until finally it prints this third one here where we do have a \n all by itself, and that will produce a new line character and move the cursor down to the line below it. So let's give it a try. So go over to our program here, and let's say we want to break this up into multiple instructions. So for this one, let's erase this part, and we'll say first we'll just print hello, And then we'll have another printf instruction. And I'll say world, semicolon, printf, how are you? Just like that. Then I'll say printf \n all by itself. And remember to put semicolons at the end of these lines, just like this. And then finally we'll say printf I'm fine, and a semicolon at the end. So before I run this program, can you try and guess what the output will look like when we run this program? Okay, so let's go ahead and run it now, and we'll see if it matches what you're expecting. There we go. Hello world, how are you? So remember, since we didn't put any spaces here after our hello or after our world, it's just going to lump them all together in one big word like this, one big line. So if we wanted to fix this, then we would need to manually insert our spaces like that. So now if we run this again, we should see some properly spaced words. There you go. Hello world, how are you? I'm fine. And I'm fine prints on its own line because of this \n character here. So that's all pretty easy to understand, I think. Let's go ahead and continue reading and see what it says. It says, notice that the \n represents only a single character. An escape sequence like \n provides a general and extensible mechanism for representing hard-to-type or invisible characters. Among the others that C provides are \t for tab, \b for backspace, \quote for double quote, and \/ for the backslash itself. There's a complete list in section 2.3. So why don't we give one of those a try? Let's say we want to print a double quote and a backslash. So let's say right here we want the word world in quotes. So in order to print a quote, then I put a \quote like that, and then I'll put another one after the word world, \quote. So that should print our world word in quotes. And what if I want to print a backslash? Where should I put it? Maybe I'll put the backslash, I'll just jam it in here between the U and the question mark. So I'll put backslash and backslash. And now let's run this and we'll see how this looks. Okay, now we have our hello world in quotes, and we have our backslash printed at the end of the sentence. So there you go. That is our brief introduction to C. Hopefully you enjoyed our Hello World program here. And if you want to go ahead and try it for yourself, maybe you'll be inspired to start learning more C programming as well. So that's it for now. As always, thanks for watching, and we'll see you next time.